All right, so welcome everyone to your 176 review. My name is Carl, and I'll be leading your review session today. And just a real quick, just a quick disclaimer that this review session is being recorded and will be uploaded to our UNR Math Center YouTube channel. So if there are any questions that you want to look back at how we went over, the recording should be uploaded within a couple hours after this review session is finished. So feel free to take advantage of that. So at any point in time, if you guys have any questions or need me to explain something further, please feel free to either unmute yourself or type your question in the chat. I'm keeping an eye on that as we go along. All right, so just to double check, does this review material match the one that you guys have received? Or another question could be, did you guys receive any review material?
We got an exam, like a practice exam, but I haven't had time to look at it.
Got it.
Yeah, me either. I'm looking at it right now. I'm about to.
All right. Yeah, if you guys could just quickly let me know if this practice exam matches what you received, so that I'm working on things that you guys are covering.
Yeah, I'm looking for it right now.
All right. Yeah. No worries. Take your time. We've got, if this is the material, we've got quite a lot of time on our hands. It's not a long exam, so we should be fine. Yeah, so go ahead and look at that. Just let me know when you do have it, if this does match.
Emily, do you see where she posted or where he posted it?
Yeah, it's homework.
Homework on WebAssign, right?
Yeah.
Okay.
It's similar, but I think ours is a little bit different.
Are you guys
because
able
it doesn't
to
have like the limit equals.
Got it. Are you guys able to actually download that document file, and then could you upload it to the chat? I'll go ahead and work on that document, whatever you guys have instead. Yeah, so if one of you could go ahead and please download that and just put it in the chat, and then we'll work on that one.
Okay.
Thank you. Yeah, so this happens sometimes where we receive the wrong files or we just mix up what we have. So not a big deal. We'll just work our way out. Let me stop screen sharing for now. And I'll just wait till we have that in the chat box. So
yeah, I see the exam practice he posted in WebAssign, but I don't know if you can download it since it's like on the website.
oh, it's on
WebAssign,
not Web Campus. Okay.
Yeah, so it's kind of tricky.
So,
I see somewhere it says you can print the assignment though.
if you can print the screen, that might work as well, or print the assignment like you're saying.
Yeah.
We'll just give this a couple of minutes to try, and if it doesn't work, I'll just go with what I have.
Okay, that's fine.
Yeah, I'd much rather prefer work on the actual practice that you guys receive.
Did someone say there was a print screen option?
Yeah, you should be able to like print it and then
You can do screenshots, but it's only going to do like 2 questions at a time. 2 questions.
So if you right click the screen and you should be an option to print, and that should actually print the entire screen. Hopefully, you might want to just check it because WebAssign might not capture the screen as well as we want it to. And when
yeah, okay, I got it. Cool.
Awesome. And you should be able to save that as a PDF when you print that.
Yeah, I'm doing it right now. Cool.
All right, thank you. And then just go ahead and just put that in the chat and we'll see how that works. First review of the summer session, and we're already having difficulties. Pretty nice.
All right, I just saved it. So
And you can either drag and drop it into the chat box, I think, or you can select the file button and then actually find it that way. Whichever works best. There we are. Okay, I see it. Let me go ahead and download it to the desktop. Okay, and then let me open that real quick. There we are. Hopefully this opens correctly. Yes. Okay, so it looks like I have it and it is opening up. Let me quickly take a look at how this looks so that I can see if it's, oh, that did not work the way I wanted it. What is this? Okay, that's weird.
It looks good on mine when I opened it up, but I don't know how it's looking for you.
Yeah, no, it's just the software that I'm using to open. It's not working as well. So there we go. I got something working. This will do. Let me go ahead and set this up correctly then. Let's put this here. Share screen. Okay, I should be able to. Are you guys able to see my Chrome browser with the PDF?
Yeah.
Wonderful. Okay, so yeah, we can go ahead and do these then. And let me go ahead and pull up the chat as well. Okay, here we are. All right, so now we can go ahead and get started. Sorry, that took a bit. Let me zoom in a bit so we can see better. All right, so let's just go. So the way I'm gonna do it right now anyways, is I'm just gonna go ahead and work through the problems from start to finish. And if anyone has a question in particular that they want to go over first, or before we end the session, then I'll go ahead and jump to those if we need to, okay? So any point in time, if you guys can go ahead and start looking at the future problems, if there's a problem that you really want to make sure we cover, I'll go ahead and do those first, okay? But until then, I'm just going to start from the beginning and let's work our way through these. So question 1, find the slope of the line that passes through the pair of points, right? So whenever we're trying to find the slope, let's remember the equation. All that is, oh, that's not what I want. All the equation is for slope is m is equal to change in y over change in x, or sometimes written as y2 minus y1 all over x2 minus x1, right? And okay, I see someone sent me some questions. I'll go ahead and make sure we do those. But continuing on, so this is simply just remembering the formula for change in slope. It's for slope rather. It's simply just the change in y's and the change in x, or y2 minus y1 over x2 minus x1. So let's just say that this is 0.1 and this is 0.2. So y2 would be 8, y1 is 7, x2 is 4, x1 is 3. Simplify that out, you get 1 over 1 or 1. And that is this, that's simply the slope right there. So the slope would just equal 1. All right, very straightforward. Let's go ahead and move on. How do I scroll? Why isn't it scrolling? There we are. No, okay, this is going to be annoying. Clear this. So number 2, find an equation of the line that passes through the point and has the indicated slope m. So could anyone tell me in chat, what is the equation of a line that uses a point and a slope? Or if I'll give you the name of the line, this is going to be in, we want the formula for point slope form of an equation of a line. So what would that be?
mx plus b?
Exactly, right? Y is equal to mx plus, oh, well, this is actually slope intercept. Slope intercepts. So this requires, this would be m and the y-intercepts. In this case, we have m and a point. So we're looking for a point slope form.
Y minus y1 equals parentheses x minus x1.
Exactly, right? Y minus y1 is equal to m times parentheses x minus x1. So this right here is point slope form. It takes any points on the line and a slope, and it will eventually rewrite it into this form right here. So let's go ahead and just plug stuff in. So y is equal to, so the y1 and x1, that's just your point. So our y1 is 6, so it'll be y minus 6 is equal to m. M is -1, so we'll just put a minus sign in front of the parentheses. Then x minus x1, which is 1 as well. So this right here, if your professor accepts this, that's great. If it's on an online application, you just go with whatever format they give you. I'm going to go ahead and solve it for y just to make sure. So we'll get, before we do that, let's go ahead and distribute this first. So when you distribute the negative into the parentheses, we'll get -x plus 1. And then when you add 6 to both sides, we'll get +6 as well. This simplifies out to -x plus 7, right? And that'll be your equation of a line in slope-intercept form, the one that we're most familiar with. So that's that. Let's go ahead and move on. Oh, sorry, any questions on anything so far? Or are we all good? I'm assuming we're all good. If there's any questions, just go ahead and type and I can easily go back for you guys. So there's quite a few problems in here, and we're going to try to get as much of them covered as possible. Right? So let's go ahead and start. We've got, okay, question 3. We're given 2 functions, f and g, and we're going to perform the 4 basic operations on these functions. Okay, so we've got f plus g. So we have f of x right here and g of x right here. So f plus g is very simple. Whatever f is and whatever g is, just add them together. So let's go ahead and do that. So f is 1 over x squared plus 10 added with 1 over x squared minus 10. So in order to add two fractions with different denominators, we have to make them have the same denominator. So all I'm going to do is I'm going to multiply this one by the denominator of the other over the denominator of the other. And I'm going to multiply this one by the denominator of the first fraction, right? So then when we do that, we end up with x squared minus 10 over x squared plus 10 times x squared minus 10 plus x squared plus 10 all over the same denominator, right? And that right there, now that they have the same denominators, now that these two are equal, we can go ahead and combine the fraction. We'll get x squared minus 10 plus x squared plus 10 all over x squared plus 10 times x squared minus 10. Right now, this is where we have to start simplifying. If we look at just the top, we have an x squared minus 10 plus an x squared plus a 10. So this -10 and this +10 will cancel each other out. And all we're left with is x squared plus x squared. So on the top, we'll have 2x squared. All right. And now if we look at the bottom, if we FOIL this out, if we were to FOIL this out, I'm going to quickly point this out. I don't know, does anyone recognize something special about these two binomials? There's actually a special case. Anyone recognize this? Doesn't seem like. All right. So this right here, actually, if we write this in a general form, this is actually equal to a squared minus b squared. This is the difference of squares. This is a nice formula. What am I writing? That's not what I wanted. I want squares. The difference of squares, all it says, if you have a squared minus b squared, it can be factored out to a plus b times a minus b. And what we have right here is a difference of squares. We have a is our x squared and b is our 10. So if we were to do the little shortcut, then all it is, it'll be x squared squared minus 10 squared. And if we simplify that out further, that'll be 2x squared times x to the fourth, right? Because x squared squared, when you have an exponent to an exponent, you multiply the two values. So 2 times 2 is 4. And then 10 squared is just 100. So this little shortcut right here is just a little quick shortcut in order to realize what this is. It's okay if you don't recognize it on the test. If we were to go ahead and actually factor out this by hand, multiply this out by hand. So if we FOIL it, let me write the correct problem first. If we were to FOIL it, so first we've got x squared times x squared, that's x to the fourth. X squared times -10, that's -10x squared. Inside is plus 10x squared, and then outer is minus 100. And we'd see that these two terms will cancel out. So all we're left with is x to the fourth minus 100, right? So when in doubt, just FOIL it and you'll get the same answer. This is just a little shortcut if you can see it on you when you actually take the exam, but just helps save a little bit of time. But yeah, this right here, this 2x squared over x to the fourth minus 100 is our answer for f plus g. Any questions on that process? All we really did was the complicated part is to remember to combine make them have the same denominator, right? Common denominators. So assuming that there's no questions so far, I'm going to go ahead and move on. Again, if you do have any questions, please feel free to interrupt me. I'll go ahead and explain it further. So f minus g will follow a very similar process in that we have to, again, make sure that they have the same denominator, right? So this will end up being, when you multiply it the same way we did in f plus g, we'll get x squared minus 10 on the top of this one, x squared plus 10 times x squared minus 10 minus x squared plus 10 all over the same denominator, right? So the biggest difference here is this minus. This minus sign will sometimes trick a lot of people up. What do we have to do with this minus sign to these top terms right here?
Just distribute.
Exactly, right? We have to distribute it. That's something that we sometimes forget. So if we look at what's going to happen, we have x squared minus 10. We read that as the same. We have the minus parentheses the top, so that we can actually visualize that we are going to have to distribute afterwards. And then we still have the same denominator as the previous problem. So if we go ahead and simplify this now, the top ends up being x squared minus 10 when you distribute the negative minus x squared minus 10, right? And then all over, we know from the previous problem, this is going to be x to the fourth minus 100. If we simplify the top now, we have an x squared and a negative x squared. These two terms cancel each other out. And all we're left with is -10 minus 10, which is -20 over x to the fourth minus 100. And that will be your answer there. All right. So same process. When you have two fractions with different denominators, make them have the same denominator, common denominators. But the thing you have to remember, if you ever subtract a fraction, don't forget you have to distribute the minus sign to the numerator. You have to distribute it. Otherwise, you'll get the wrong answer, okay? Don't forget that part. But yeah, that one is very similar to, these two are very similar in terms of the process. So let's go ahead and move on. Let's go ahead and do f times g now. F times g is going to be simply, you multiply the two fractions together. And this actually comes out to be something real simple because the numerator is just 1. And the denominators is, again, the same thing as we had before. It'll be x to the fourth minus 100. And that's right there. That's fg. If we go ahead and do f over g, though, let's see what we have. 1 over x squared plus 10 all over 1 over x squared minus 10. So what do we do when we're dividing by a fraction?
The reciprocal.
Right, we multiply the first fraction by the reciprocal of the second fraction. And all we mean by reciprocal, I can't spell, reciprocal, is just flip the fraction. So reciprocal of this will just be x squared minus 10 over 1. Right? And then now you can multiply that out. You'll get x squared minus 10 over x squared plus 10. And this cannot be simplified further. So that's the answer there. Any questions on this entire problem? Question 3, we went over the 3 basic operations when you're dealing with 2 functions. Any questions? Nope. All right. Again, any questions at all, just feel free to interrupt me. So we might start skipping some of these problems because they might be a little repetitive. Okay, this one's not. Let's go ahead and do this. So this time we're doing composite functions. So they want us to find f of g and g of f. So this is equal to f of g of x. And this is equal to g of f of x, right? You just plug in the second function into the first. So if we want to find f composite g, again, this is going to be f of g of x. So all we need to do is plug in this function g into the x of the first function. So f of x is the square root of x, or in this case, it'll be g, 1 minus x minus 3 plus 3. And that right there is find the rules for the composite. Interesting. Okay. But yeah, that's all you do. And then you can go ahead and plug stuff in as need be. I don't think they're going to ask you to simplify this. Well, I mean, if they do, you can turn this into one fraction by multiplying this by x minus 3 over x minus 3. Then you'll get the square root of 1 plus 3 times x minus 3 all over x minus 3. And then you can simplify that out further, right? So it'll end up being 3x minus 2, something like that. And then if it asks you to simplify it, then yeah, you'd simplify it. But I think this, when we had just this would be enough. I don't know. Depends on what your professor requires or what the software you're using requires, right? So that's what all f of g is. You just plug in the second into the first. So if we go ahead and do, go ahead.
For some reason, I was trying to do that one and it kept showing up as wrong. So I think we might have to simplify it all the way out because I got the same answer, the 1 over x minus 3 plus 3, like square rooted, and it was showing up as incorrect. But then on the g of f, it was coming out as right. So it was kind of weird.
Interesting. Okay, so then if it doesn't accept this form and if all of your exams are actually through WebAssign, yeah, WebAssign is not a nice one. It's not exactly the nicest. Wait, no. Wait, this is WebAssign, right? WebAssign, not MathLab. Yeah, WebAssign. That's weird. WebAssign usually accepts things not in its simplest form. Huh. Maybe I did something wrong. Let me take a look here.
Normally there's like a practice function for these, so I normally do that to check to see how WebAssign wants it done.
That's a good method to use, yes.
Yeah, me too. But on the exam practice, he like disabled it.
Wow.
So a new problem every time.
Got
Okay,
it. So
damn.
then what that's sort of telling me is since he just then it's probably this answer that he wants for the first part. So you're gonna have to simplify it all the way. So then these steps right here, turning this 3 so that it has the same denominator as the first fraction. And then when you combine it, you get this sort of thing and simplify it. This is probably the answer that he wants then. So
okay.
Make sure you take it all the way through in terms of simplification. So thank you for bringing that up. That's a very good thing to remember or to note. Go ahead.
Do you not distribute the 3 first?
Sorry, yeah, I sort of skipped a step here. If I go ahead and actually distribute that, this will be 1 plus 3x. Oh, I did the math wrong. Oopsies.
Yeah.
Yeah, sorry about that. Good catch. That'll be 3x minus 9 over x minus 3. So this is actually incorrect. Let's ignore that. The actual answer is the square root of 3x minus 8 over x minus 3. Good catch. Yeah, so this will be the answer for this problem. Yeah, good catch.
Okay, that makes sense.
Do
Thank
your
you.
distributions correct. No worries. Yeah, thank you for catching that problem. Whoever was speaking about that. So let's go ahead and try to do g of f now. G composite f, again, which is equal to, let me actually type it correctly. G of f of x, which is, so we have g, 1 over x minus 3. So x in this case will be f. So that's square root of x plus 3 minus 3. And did WebAssign accept this, or do we have to simplify this as well?
It accepted that one. That's why I thought it was weird that one
Interesting.
was accepted and the other one wasn't.
Okay, so it accepted this, but it didn't accept the other one. That's really odd. So the reason why I find it odd is because technically this is an irrational function because there's a square root in the denominator. Just in case that was a lucky accepting thing, maybe we just had numbers incorrect about. I'm going to go ahead and show you how to simplify this too. Because again, the main reason why I'd say you might want to simplify this is because normally we don't like square roots in the denominator. So in order to quote unquote rationalize this fraction, we multiply it by the conjugate of wherever the square root is. So the square root's in the denominator, the conjugate is the same exact thing, all the same values, except you swap the sign in the middle. So it'll be plus. And then from there, you can go ahead and multiply that all out. So you get x plus 3 in the numerator. And then this is a difference of squares. So I'm just going to jump ahead. Since it's a difference of squares, it'll be the first term squared, which is going to be x plus 3. And the second term, which is 3, or minus the second term squared. So 3 squared is 9. Let me write that properly. And then if you simplify this out, you'll get x plus the square root of x plus 3 all over x minus 6. And yeah, this is the rational answer. So, but yeah, if WebAssign accepts this, then by all means, just go for it. But if it doesn't accept it, then you know what the process is now. You have to multiply by the conjugate, okay? The conjugate. That might not be how you spell it, but you know what? English is not what we're here for. All of the conjugate is, it's the exact same thing as the denominator, except the sign is switched, right? You just swap the sign. If it's negative in the original, multiply by the positive on both top and bottom. If it's positive here, then you do the minus sign, right? All you do is swap the sign. All right, so that's all that question 4 is, composite functions. The process is straightforward. It's just we can kind of trip ourselves up when we simplify it, right? Sometimes there's some simplification things we need to be aware of. So let's go ahead and look at the next question. We got some money problems, word problems. Okay, a manufacturer. There we are. Nope, that didn't do it. Perfect. Okay. A manufacturer has a monthly fixed cost of 42.5K and a production cost of 6 per unit. The product sells for 11 per unit. Find the following functions in dollars and compute each profit in dollars. Okay, so cost function is simply, I'm assuming X is the number of units. Yes, it doesn't specify, but yeah, we're going to assume X is the number of units. Cost function is the production cost right here and monthly fixed cost. Okay, so with looks like you guys are only learning to use linear functions. So we're going to assume that it's going to be all in the form of y equals mx plus b, right? Y being whatever function we're working with. So c of x in this case, the cost, well, we have a monthly fixed cost of 42.5K. So that fixed cost, as in it's always the same, it's constant, right? So that'll be our b. So we're going to have a plus 42,500 as our b. And in terms of X is the number of units we're producing, and we have $6 for each unit. That's the production cost. So all it will be 6X plus 42,500, right? Very straightforward. It's just making sure you understand, recognizing what cost goes where in the equation. If you have a rate in terms of cost per unit, that's your slope, right? And if you have a fixed cost, that'll be your b. All right, so now we're looking at the revenue function. The revenue function will simply be how much are you selling it for, In this case, we're selling it for 11 per unit. So R of X is simply 11X, right? And lastly, for profit function, profit is always going to be the revenue minus the cost. So it'll be R of X minus C of X. So in this case, revenue is 11X minus, whenever you're subtracting a function or subtracting something big, I always suggest putting everything in parentheses, because then you'll realize and remember you have to distribute this negative to both parts, right? So then you'll get 11X minus 6X minus 42,500. This simplifies out to be 5X minus 42,500, right? And that is our profit function. Good. And then the last part is compute the profit or loss corresponding to the production level 6,000 and 11,000. So this is just plugging things into a calculator. I'm going to assume you guys are allowed a calculator, hopefully, because I would not want to calculate these by hand.
Yeah, we get one.
All right. So 5 times 6,000, that'll be 30,000. So this will be a loss, right? What's that? Negative 12,500, I think. So a loss of $12,500. So assuming, yeah, because they don't specify, you put a negative, I think, here when you plug it in, I think. And then when you take the 11,000, let's see, multiply it by 5. This will be 55,000 minus 42,500. This will be, what is that? 12,500. Positive 12,500. So this one, when you produce 11,000, you get profit. When you produce 6,000, you lose money. All right. So again, the main concept you need to remember here is recognizing what each of these costs and each of these numbers provided represent. If you have a fixed cost, that usually means the b-intercept or the y-intercept, so that'll be b. If you have a cost per unit, that's your slope, m. And if you have a product sells for dollars per unit, that's simply going to be another type of slope, right? Except for the revenue. So it's recognizing what goes where, right? As long as you can recognize and remember what number goes to what variable in which equation, you'll be golden. So from there, it's just straight algebra. All right, so let's go ahead and move along to the next problem. Market equilibrium, weekly demand and supply, given by this respectively, where P is dollars, X is units of 100. Find the equilibrium quantity. All right, so the equilibrium quantity, so this is demand and supply. Equilibrium quantity, all it is you set these two equations equal to each other, right? So we'll have negative 0.1x squared minus x plus 76 is equal to 0.1x squared plus 2x plus 56. And then if we go ahead and subtract, move everything to one side, I'm going to bring everything to this side. So that we'll be adding 0.1x squared, adding x, and subtracting 76 to both sides. What do we get? We get 0.1 plus 0.1, that's 0.2x squared. We have 2x plus x, that's 3x. We have 56 minus 76, that is minus 20, I believe. Is all equal to 0, right? So now that's equal to 0, we can try to factor this out. I'm not even going to bother trying to do this, I don't think. Let's just go ahead and plug it into the quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac all over 2a. And if I go ahead and get a calculator real quick, or if so, does someone want to compute this for me? That'd be great. If not, I'm just going to pull up Desmos. See if I can type this in. We'll use the positive because we don't want a negative answer. Square root of 9 minus 4 2 times all over 2 times 0.2. Okay, that's a nice answer. Comes out to 5. Okay. Perfect. So we have right here is equal to 5. So, well, 500 units. So we'll just put 5 though, because x is in 100. So x is equal to 5. In order to find the equilibrium price, all we need to do is plug in the value we have for x, right? And since both of these, since this is the intersection point, it doesn't matter which function you plug it into. So pick your poison. It really doesn't matter. Let's go ahead and pick this one since we only have to deal with positive numbers that way. 0.1 times 5 squared plus 2 times 5 plus 56. Let's see, this is 25 times 0.1. That'll be 2.5 plus 10 plus 56. This will be equal to 68.5, I believe. So $68.5. Any questions on that? So I know I sort of rushed through that problem, but the main thing to remember, if you're dealing with equilibrium of supply and demand, you just set them equal to each other. That's all it is. Right? Very straightforward. And then when you set them equal to each other, you can solve for x using the quadratic formula, and then you just plug it in to get the price. All right, hopefully that's clear. Let's go ahead and move on. Number 7, cost of producing surfboards, total cost. What's the question? Okay, it's asking for the derivative. All right, what is the rate of change of the total cost? Yeah, okay, let's go ahead and do this. So now we're into derivatives, right? And I'm assuming you guys have learned like the derivative rules, like product rule, power rule, and all that.
Yeah.
Okay, safe to assume that. Okay, so I don't have to do the quotient, differential quotient. Perfect. Okay, so we're given this cost function, and it's telling us to find the first derivative. So the first derivative, or c prime, let's go ahead and see if we understand, if we remember our derivative rules. So whenever we have multiple terms added to each other, we can just take each term by itself. So let's take the derivative of negative 9x squared. What is that? You don't get a guess, an answer?
Negative 18x.
Negative 18x, right? All you do is if you ever have a power, or so let me write it over here. If you ever have a power, all it is, the derivative is you subtract 1 from the exponent and you bring the exponent out. So what I mean by that is you bring the exponent out. So I brought the 2 down and you subtract 1 from the exponent. So I brought the 2 out and I'm subtracting 1 from the exponent. This gives us negative 18x to the 1, or just x, right? Following the same process, if we take the derivative of 500x, well, here's a little shortcut for you. If you ever just have x to the power of 1 and you're taking the derivative of that, it's just the number in front. So that'll just be plus 500. And now if we take the derivative of 110, if you're ever taking the derivative of a constant number, meaning there's no variable, it's just a number, it's always equal to 0. So we just ignore that, right? So all we have now is the first derivative, or c prime, is equal to negative 18x plus 500. Any questions on how we found that derivative?
That actually made way more sense. Like I get it now.
Awesome. Yeah, I'm glad. Yeah, so for these types of, whenever you have like polynomials functions where you just have different powers, they tend to be very straightforward. Again, the process is whenever you have a power, you go ahead, take whatever power it is, take it out, bring it to the front, and then subtract the power as well, right? That's all it is. Very straightforward. Don't overcomplicate it, right? And some shortcuts again, whenever you have any number in front of an x, like x to the power of 1, if you're taking the derivative, it's just the number in front, including the sign. So if I had minus 500, it'd be negative 500, right? So always watch out for the sign. And if you're ever taking the derivative of any number just by itself, it becomes 0. So we just ignore it. So yeah, very straightforward there. And now if we move on to part B, what is the rate of change of the total cost when the level of production is 6 surfboards a day? So whenever you're asking for rate of change and they give you a certain x value, this means, so if we sort of think of it in terms of conceptually what's going on, cost will give you the dollar cost whenever you plug in an x, right? The derivative will actually give you the dollar per x whenever you give it an x. So all that's really saying is the derivative will give you a rate, right? So this will give you the dollars, the flat cost. C prime will give you the rate, or the rate of change of the total cost. So in order to calculate this question, all you're doing is taking C prime at x equals 6. So if we go ahead and do that now, that'll be -18 times 6 plus 500. And this is -106, I think. No, 108, sorry. Is that correct? I think that's correct. Plus 500. And this should come out to be 392, I think. -108 plus 500. If anyone wants to double check, sorry, if -18 times 6, if anyone wants to double check that's correct, I'm pretty sure that's correct. Okay. I can actually double check myself. I have Desmos. Let me do that. -18.
It's right.
6. Yes. Mental math is not failing. Okay. So yeah. So the key thing to remember here, whenever you're asking for rate of change of total cost, when you're given the cost function, this is all it's asking for the derivative and then at some x value, right? So it's always it's good to understand what the derivative of the cost function means in the context. So if C represents the cost, the total cost function, C prime, or the first derivative of the cost function, represents the rate of change of the total cost. Okay, so just some words there, but if you're only worried about trying to solve a problem, if they're asking you to solve the derivative, chances are you might need to use that derivative in the next part, right? And these are usually successively built problems. So let's go ahead and move on. What's our time looking at? We're about halfway through, and we're about halfway through the thing. Yeah, so it looks like we're good on time. Question 8, use the 4-step process to find the slope of the tangent line. Oh, you have to do difference quotient. Okay, so this is difference quotient. This is what you learn the definition of a derivative. It's tedious, but we have to do it anyways. So the difference quotient is right here. They broke it up into steps, so we're going to follow the steps. So we have f of x is equal to -1/10 x squared. They want us to find what f of x plus h is. F of x plus h. So the thing that I like to do is whatever's in the parentheses is what I'm going to replace the original x with. So what that means is I'll have -1/10 parentheses x plus h squared. And then if I want to go ahead and simplify that out now. So this will simplify out to x squared plus 2x plus h, sorry, x times h plus h squared. This is just me using this, if in case you were wondering. A plus b squared is equal to a squared plus 2ab plus b squared. Again, if you don't remember this, totally fine, just FOIL it out. So what I mean by that, you can break it up into this, right? X plus h times x plus h, and then FOIL it that way. You'll get the same answer in the end. I'm just doing this to save some time, okay? So go ahead and confirm that yourself if you're a little confused. So yeah, that's the first step right there, f of x plus h. Now they want us to take what we have, f of x plus h, and subtract the original function from it. So what that means is we take what we just have right here, -1/10 times x squared plus 2xh plus h squared, and we're subtracting the entire original function. So we're going to subtract in parentheses. I always put a function in parentheses so you never miss the distributing of negative signs. -1/10x squared. So I should have distributed the -1/10 here first. So let's go ahead and quickly do that. If we distribute the -1/10 across, we'll get -1/10 x squared. Let's see. -1/10 times 2 is -1/5 x to the xh minus 1/10 h squared. And then now we do this part, the distribution, minus the negative distributed into the negative. So negative times negative is positive 1/10 x squared, right? If we simplify this further, if we take a look at this, -1/10 squared plus 1/10 squared, they cancel each other out. All we're left with is 1/5 xh minus 1/10 h squared, and we'll leave it like that. Now, if we go ahead and do step 3, we take this answer right here and we divide it by h. So all we're doing is we're taking the negative 1/5 xh minus 1/10 h squared all over h. So if we take a look at the top, we can actually pull out an h from the top. So we'll get an, if we pull out an h, we get negative 1/5 x minus 1/10 h. Right? I just pulled out this h, and when you pull out an h from h squared, you just subtract 1 from the exponent. So we got h times this whole thing all over h. This will cancel out. All we're left with is this now, right? So that's what this whole thing equals. The difference quotient equals 1 over 5 x minus 1/10 h. And lastly, if we take this right here, let me write it over here so we can actually see it clearly. All we're doing now is we're taking negative 1/5 x minus 1/10 h. We're taking this as the limit h approaches 0. All that means is you replace h with 0, so that we got negative 1/5 x minus 1/10 times 0. Anything times 0 is 0, cross that out. The answer is just negative 1/5 x, right? So that's actually doing the difference quotient, the limit definition of a derivative. Very tedious, but it works with every single problem. But yeah, that's the final answer, negative 1/5 x. Again, this is the definition of a derivative, right? So if they ask you to do the definition of a derivative, like this whole limit process, then you have to do all this work. But if they just ask you what the derivative is, you can use the power rule, f prime of x. We do the power rule. Well, let's see, what do we got here? Following the rule we said earlier, we bring down the power. So 2 multiplied by the original thing, except we subtract 1 from the exponent, right? So now if we go ahead and simplify this out, 2 times negative 1/10, that's negative 2 over 10, which is equal to negative 1/5. And then if we go ahead and subtract that, it'll be x, right? So basically our little power rules and all those rules are just a lot quicker than doing this whole thing, right? But it comes out to the same answer. But yeah, that's just your example of your definition of a derivative problem. If you have to do this, some things that I would like to highlight to make sure that you do not forget. When dealing with this step right here, all you're doing is you're taking this whole parentheses and replacing it with the original x, like I did right here, right? Another important thing, when you're doing this step right here, where you subtract the original function, do not forget to distribute the negative into the function. That's very important and often happens when we go over these problems. And then something you should know, if you're doing everything correctly, in step 3, you should be able to cancel out an h somewhere. If you don't, you might want to double check your algebra. So yeah, step 3, a good way to check, did you cancel out an h? If you did, perfect, you probably got the right answer. If you didn't, double check. And then lastly, for the limit, you just plug in h equals 0 and you'll get your final answer in terms of just x, right? So, all right. Any questions on that process? That was quite tedious, but that'll probably be the only one we'll do about these types of problems. All right. Any questions? No questions? All right. Let's go ahead and move on then. So we've got about 30 minutes left. I might start skipping some problems because I know I have I've requests for 2 different problems. Yeah, okay. Let's actually do this one problem, then I'll start skipping. Okay, so question 9. Find the slope of the tangent line to this graph at the given point. So like we sort of went over in that cost problem we did before, if we have f of x, this will give us sort of a position. If we want to find the tangent line at any point, we need to find the first derivative of the function, and we'll see why. So if let's first take the derivative of f, and we'll get, doing the power rule. Well, again, we said if there's an x to the power of 1, the derivative of that's just the number in front, and the derivative of a constant is 0. So the first derivative is just -3. And in order to find the slope of the tangent line at some point, we need to take the derivative at that point. So if we plug in this point into this function now, that's at x equals -1. So f prime of -1, well, it's always going to be -3. So what does that tell us? The slope at -1, 9 is -3. So m is equal to -3, right? And in order to form the equation of the tangent line, we go ahead and use point slope form. And this will simply be y minus 9 is equal to -3, x minus -1 is +1. Simplify that out, you'll get -3, x minus 3 plus 9, which is equal to -3x plus 6. Right? And a good way to check if you did it correctly, if you plug in the points into this, you should get the correct answer. So if I plug in -1 into this, I get 3 plus 6, which is 9, which matches the point that we started with, right? So the main thing to know here, if you ever need to find the slope at a point, your step 1 is find the derivative. Step 2 is plug in the points. And step 3 is use the point slope formula. Right? Very straightforward process. Any questions on that? No questions? All right. Let's start. We might need to start skipping here. We got 30 minutes left. Find the derivative. Okay, so this is actually going to be real quick. Maybe we can speed through these. So number 10 is finding the derivative using the rules of differentiation. We have a power, so we use power rule again. Power rule says you bring down the power. So we're going to bring that down, 5.2. And we're going to write the original thing. And then we're just subtracting 1 from the power. That's all it is. So it's going to be 5.2 times x to the 5.2 minus 1 is 4.2. And that's our answer for f prime. Very straightforward. Right? Power rule. It'll be probably the one you use the most. So get comfortable with it. All right. Number 10, done. Let's look at number 11. Consider the following. Oh boy. We write the function by dividing each term by the numerator and some of the result. Okay, yeah, that's actually not bad. So it's at first asking us to simplify this. And what it means by that is whenever we have terms being added or subtracted in the numerator of a fraction, you can break it up into this. You can break it up into all the separate numerators, right? All the separate terms. So you can get all the different fractions. So -7 over x. And then if you simplify this out, x cubed over x, x squared over x, that'll be 9x. X over x is 1. And then -7 over x, I'm going to write it as -7x to the -1, right? Because whenever we have 1 over x, that's the same thing as saying x to the -1, right? So I'm just going to write it like that. And the reason why I'm writing it like that is because it'll make our life a little easier when we take the derivative. So this right here is your answer for this part. Now let's take the derivative of this. We're going to, since it's all a bunch of terms added or subtracted to each other, we take the derivative of each term separately. So the derivative of f of x, let's see. Derivative of x squared, we bring the power down, subtract 1 from the power. 2 minus 1 is 1, so it'll be 2x. Plus 9x, so the derivative of 9x, again, we said whenever we're taking the derivative of x to the power of 1, it's just a number in front, so it'll be plus 9. The derivative of a constant term is 0, so we ignore that. And if we take a look at the last one, derivative of x to the -1, so we follow the same derivative rule. We bring down the power, so bring down -1 times the original thing, but subtract 1 from the exponent, right? So what does that simplify out to? Let's see. We'll get, well, -1 times -7 is +7. and then it's x. The -1 minus 1 is -2, right? So all that means is if we were to write this in a separate way, that means it's 7 over x squared. And I'd say that either of these two answers are acceptable, usually, because they're both as simplified as possible. All right. Any questions on how we did this problem? No questions? All right. Probably the thing I want to point out is this sort of trick where you sort of break it up into these different functions works the best when the denominator is just a single term, like x, for example. If it was like x plus 2, I wouldn't break it up. That's a little more complicated. It might not work as pretty. But if it's just x or like a number times x, like 3x, it'll work pretty well as well. All right. So that's that trick, simplifying problems to make it easier for you to derive. Let's take a look at the next one. Number 12 and 13. Find the derivative of the function, use the slope. Okay, so I'll go ahead and do this one. I will not do number 13. It's very similar to that one problem we did earlier. I'll just rewrite the steps for you there. Okay, but anyways, 12. Find the derivative of the function using rules of differentiation. Same deal, power rule all the time. Well, 5t squared, bring down the 2, multiply it by the same thing minus 1. This becomes 2 times 5 is 10. T, 2 minus 1 is just 1, so 10t. Now this part is the interesting part. Whenever you have the square root of something, another way we can write it, if you remember, is you can write a square root as a power, and that'll become the power of 1/2, right? So really, what we have, instead of the square root of t cubed, we have this t cubed to the power of 1/2. And if we go ahead, we have an exponent to the power of an exponent. You multiply that together, there'll be 3 times 1/2, which is going to be 3/2, right? And now this is a lot easier to deal with. If we're taking the derivative of t to this power, we just follow the power rule. We bring down the exponent, and then we subtract 1 from it, right? And if we go ahead and simplify that, we get, well, this can be rewritten as 3/2 minus 2 over 2, right? Because this is still equal to 1. So 3 minus 2, which will be 1/2. And this will be our answer, which you can also write as this. Any questions on that? I know this is again using power rule, but it's recognizing that this trick right here, making sure that you understand if you have a square root, you can turn it into a power, and then it makes life a lot easier. Any questions so far? No, doesn't seem like it. All right, let's go ahead and for now, I'm going to skip 13 because it's very similar to the problem we did before. Again, the rule, the order, what you need to do, find the derivative first, then plug in the points, and then point intercept form, right? That's all it is. Follow that order, straightforward. And this is just a quadratic equation, so finding the derivative will not be too difficult there, okay? Just follow your power rules like we've been going over. So let's go ahead and skip this. Let's try to go to the problems that were requested. We're almost reaching there. Okay, let's go ahead and do this one. This one's a little interesting. So what we have here is we have some function inside a parentheses, but we also have a power on the top. So this is where we introduce the rule chain rule, if that rings a bell. All chain rule means, I'm going to write the generic equation, but I'll go ahead and explain what it really means. If you have a function within a function, the derivative of this is the derivative of the outside times the derivative of the inside. Now that's very abstract. What does it actually mean in terms of this problem? Well, and what do we mean by what is the function inside and what is the function outside? Well, this inside the parentheses, I like to treat as the inside function. And the power on the top is the outside function. Now, what does this actually mean for us? Well, let's go ahead and see what happens. If we go ahead and just do the parentheses thing. So let's just leave the parentheses empty for now. But we have the power of 3. If we take the derivative of that, we have to bring the power down, keep whatever is inside the parentheses the same, and subtract 1 from the power. So 3 minus 1 is 2, right? So that handles this step right here. Now, what is inside the parentheses? Well, inside the parentheses was 2 minus x, right? So 2 minus x, 3 times 2 minus x squared, that is what this step is right here, right? Now, chain rule says we also have to do multiplied by the derivative of the inside. Well, what is the inside? The inside was 2 minus x. So what is the derivative of 2 minus x? Well, do each part. The derivative of 2 is 0. The derivative of negative x is, again, we have an x to the power of 1. Just take the number in front. So that's minus 1. So the derivative of the inside, or g prime of x right here, we're going to multiply by negative 1. That's what this is equal to, right? So again, just to recap what we did, using the chain rule, we first looked at the outside function. What is the outside function? It's this power in this case. So what do we do when we take the derivative of something to a power? We do the power rule. We bring the power down and we subtract 1, like we did here, right? Bring the power down, we subtracted 1. And we do not touch the inside. We just write down the exact same thing as the original problem. But chain rule also says we have to multiply by the inside, the derivative of the inside. So we look at the inside. The inside is 2 minus x to the power of 1. And we take the derivative of that. That just ended up being equal to negative 1. And we multiply that to the whole thing that we had earlier. So this is the derivative of the outside. This is the derivative of the inside. And all we need to do now is multiply it all together. So multiplying it together, we get the negative 1 times the 3 is negative 3 times 2 minus x squared. Oh, sorry, like that. The square is on the outside. Now, depending on whether WebAssign will like that or not, you might need to simplify it. So let's go ahead and just simplify it just in case. This will be 4 minus 4x plus x squared. Again, you can double check that when you FOIL that. And this will be negative 12 plus 12x minus 3x squared. And that's your final answer. So again, chain rule. If you need to quickly go over that, I suggest looking over your notes, maybe looking at the problems where you did in your homework about chain rule, just to make sure you really understand how that works. Okay. So that's chain rule. Next question, let's see, 15. Consider the following functions. Find the derivative of each function. Okay, yeah, let's go ahead and do this. I'm not going to do all of it. I'm just going to take the derivative of f of t. This is chain rule again. So because g prime, you know how to do that. F prime, let's see what happens. So f prime of t is chain rule again. So we have a function on the inside of a parentheses, and we have a power. That's an outside function. So let's do the derivative of the outside. That's the derivative of the power. Bring the power down. Write everything inside the same. Don't change anything. And subtract 1 from the power. So that will be 3 over 2 minus 1, which is equal to 1/2. So then that's the derivative of the outside. We're not done. Chain rule says take the derivative of the inside. What is the inside? Well, that's 8t squared minus 4t plus 1. What's the derivative of this whole guy? Well, if you take the derivative, it's supposed to be an arrow, sorry. 8t squared becomes 2 times 8t, which is 16t. And then negative 4t just becomes minus 4, and 1 becomes 0. So the derivative of the inside is just 16t minus 4. So we multiply that whole thing to the derivative of the outside, right? So again, this is the derivative of the outside. This is the derivative of the inside. We simplify it. We actually can't simplify this. So it's supposed to be 16t. So we end up getting 3/2 times 16t minus 4 times the square roots of 8t squared minus 4 plus 1. And that'll be your final answer. All right. So that again uses chain rule. Derivative of the outside times the derivative of the inside. That's all chain rule is. All right. So we got about 20 minutes left. I think we're getting to the problems requested. Yeah, here we are, 16, 17. Find the percent rate of change of f at the given value of x. Percent rate of change. Oh, okay. So that's just asking the derivative at 6 and then change it to a percentage. So you just, if you have like 0.6, then it becomes 60%, right? I'll go ahead and leave this one to you guys. This one actually if we have time, I can do this, but this is gonna be a little long. This right here is a function over a function. If I have f over g and f of x over g of x. This is, you're gonna use your quotient rule, if you remember. So if you're taking the derivative of f over g, if you remember, it's just gonna be the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared, right? So that's, if we have time, I can go ahead and actually show this problem out and work it out, but this is the quotient rule, and then you're just gonna plug in 6 and make sure you turn it into a percentage. It's a really odd question. I've never seen asking the percent rate of change, but yeah, this one is derivative, but quotient rule. So go ahead and practice this if this one is tricky, because the algebra can be a little tricky. Don't forget you have to distribute this negative in afterwards. But yeah, if we have time at the end, I'll go ahead and cover that. But let's go ahead and do the problem that was requested, number 17. Number 17 is asking, for the following demand equation, compute the elasticity of demand and determine whether the demand is elastic, unitary, or inelastic. Okay, so I am actually not remembering how elasticity works. Let's see. So can anyone refer to the notes and tell me how would we find, how would we compute elasticity, and how do we determine whether it's elastic, unitary, or inelastic?
I don't even remember our teacher doing this, so
Yeah.
I don't know Emily or Jacob, but
Does anyone else have any hints at how we can calculate this?
I don't really know. I don't think he's really gone over it in depth. So that's why I was like confused too, because I wasn't sure.
Got it. Okay, so from what I'm hearing is you guys, you're unsure if he actually covered this. So what I'm assuming what happened is this practice exam is just a collective thing that he didn't update. So maybe there's some parts that he included that won't be on your exam. So let's assume the worst case scenario that it is on your exam though. So let's try to figure it out. If I remember correct, let's just Google. That's what Google's for. Calculate elasticity of demand. And then what do we got? It's change in quantity demand over change in price demand. Okay, so what do we have here? So we have an equation that's the quantity, and we have the price P.
I found the part in the book that talks about it.
Do I have to take the derivative in terms of P? And then it's just that? I think. Is that what the textbook is saying? Here's my guess at what I'm supposed to do. I'm guessing I'm going to be taking the derivative of this function in terms of p, which is just going to be -1/4, because I have p to the power of 1, so we just take the constant front, and 23 doesn't matter. And if I plug in 8, it doesn't matter because it's always -1/4. So what does that mean? If we convert that to a percentage, that's -25%, right? What does that mean in terms of Google? Let's see. There's a few ways. I know there's a few ways to calculate this. That's why. That doesn't help. If we get rid of this, we can find the see, that doesn't help. No. How do you know whether it's elastic or inelastic? It's supposed to be here. Elastic versus inelastic demand. What is so?
Is there any way I could share my screen?
Yes, actually, here, let me go ahead and stop sharing. Okay, so on 17, are you able to share your screen?
Let me see. I think so. Let me see. No, it's not letting me.
Okay, no worries, no worries. So I think I know what the definition is actually. So let me go ahead and share back. So I think if I'm understanding this correctly, yeah, elastic times that, inelastic is that. Yeah, okay. So we calculated, where am I? Where's my annotations? There it is. Okay, so in order to calculate if you have a demand function, right? So we have a function of x in terms of price. So if in order to find the elasticity, you need to find the slope at that price. So what that means is, since they're giving us a single price, we need to find the derivative of this equation. So let's just go ahead and let's say that this is a function f in terms of p, right? Because our input is price, right? So what we want to find is the derivative, first of all. And the derivative is going to be, well, again, like we said, this is p to the power of 1, so it's just a number in front, and a constant term, so it's just a 0. So the derivative of demand, the derivative of the demand equation is -1/4. So if we want to find the slope at 8, it'll just be -1/4, right? So what does this actually tell us? Well, in order to determine whether it's elastic, unitary, or inelastic, we just need to look at the absolute value of this. So the absolute value of the slope, right? So the absolute value of the slope, that's not what I wanted. The absolute value of the slope is just going to be 1/4, right? Now, in order to determine whether it is elastic, unitary, or inelastic, if I'm looking at this diagram correctly, inelastic would be when it's greater than 1, and elastic would be when it's less than 1. Yeah. So let me write that down. So elastic would be when the slope is less than 1. Inelastic is when the magnitude of the slope is greater than 1. and unitary is when m is equal to 1, right? So that is what I'm pretty sure is how you can determine whether demand is elastic, inelastic, or unitary in terms of algebra. Let me double check that just to be sure. Yeah, elastic is less than 1, right? Because you're more bigger on the bottom. Yeah. Okay. So this is I double checked, maybe emailing your professor asking if this type of problem would be on the exam. Hopefully it's not, since you guys aren't comfortable with it. But if it is, this is just what you really need to know in terms of the process. They give you a demand equation in terms of price, and they give you a price that they want you to calculate it at. All you do is take the derivative. Step 1 is take the derivative. Step 2 is plug in the price. So in this case, that we set our plug in the price P, and then that'll give you your slope M. Step 3 is take the absolute value of M and then compare it to these notes right here. Okay, so that's the best I can give you because I myself am not too comfortable on elasticity, but based on what I remember and what we're looking up, this is the sort of things that you can understand it as. Okay?
It's all good because we have I think we have class today, so we can just ask him about it during class.
Perfect. Maybe, who knows, maybe you guys will even cover that in class today.
Yeah, true.
So hopefully it's something that you guys will clarify. But yeah, that's my understanding of it. I could be completely wrong, but yeah, I double checked and clarify in class today. All right, but yeah, that's 17. And then I believe we still wanted to do, we have 8 minutes left. And I believe someone wanted us to do 19 as well. So I'm going to skip this for now. I'm going to go to 19 and see what is okay. What do we have here? The daily cost in dollars, X times the number of units produced. What is the actual cost incurred in manufacturing the 91st oven? It's the daily cost. Oh boy, I'm not remembering this myself either.
And also, as we do it, I can plug in the numbers to WebAssign to see if we got the answers right.
Nice. Okay.
So
What is the actual cost? Is this just the daily cost of producing orange given by the units produced? Now, if I'm remembering this correctly, I'm pretty sure for A, you're just going to be plugging in 91, 221, and 331 into this, right? And then B is where you actually have to calculate stuff. So marginal cost.
It's like you have to put it into the h or x plus h equation, like in for x, and then you put in the x as like 91, and then you do it twice, and then one would be 90, and then you subtract both equations for the actual cost.
Yeah, for the actual cost.
Yeah.
Oh, so
I was confused because then on the marginal cost, like on our homework, it was the exact same answer as the actual cost, but then when I submitted it for that, then it said that it wasn't the same.
Okay, so just to clarify your process, you did this. Well, no, you said 91, right?
Yeah. I'm trying to look for my notes.
Did you say C of 90 afterwards? Oh, no.
No, it's
C of 91, right?
um,
And then this is all over H, I'm assuming, when H goes to 0.
so I think you would do so it'll be like the 0.002, and then instead of the x, you would do x plus h.
X plus H. Okay, and then when did you plug in the 91? After you simplified it?
Yeah, I think so.
Okay, so since you can plug in the answer. I think what's going on here then, in order to determine A, I think what you're doing is you're taking the derivative.
Okay, I got my notes.
Okay.
Okay, so on the practice one, I actually, so it was like 2000 plus 2x minus 0.001 x squared. So I did for x, I put in the 91, right?
Mhm.
And then so on both x's or all three, you would put in 91.
Okay.
And then you do that equation minus an equation that's exactly the same, but instead of 91, you put 90.
Got it. So it's what you're saying is this. You take this equation, we plug in 91, and then we plug the same equation, we'll plug in 90 instead.
Yeah, exactly.
And this is actual cost.
Yeah.
Interesting. Interesting.
And then marginal costs, the
mhm.
90, like the first one, it was the same answer that I got for 91 at the top. But then
Okay.
for 220 and 330, it said that it wasn't the same, which was weird.
Interesting. I mean, there's a slight that was a coincidence that they were the same then. Okay, so I'm actually not that familiar with how to calculate this. I'm trying to remember it, but I'm assuming A will just be, because to me this is marginal cost right here. Was if you calculated C220 and then C221 and then minus C220, is that the answer for this, or was that wrong?
Well, on the homework, I did it exactly like that. And it said that for actual costs and marginal costs, all the answers were exactly the same. But then on the practice test, it wasn't. So I was like, because I like learned how to compute it, but then on the practice test, it shows us wrong. So I was confused now, like how to do it.
Yeah, that's a little weird. Okay, so we are coming to the end of the review session. So what I'm going to recommend you guys do, because I don't want to try to do this and then give you wrong information. I'd highly recommend you guys go ahead and, since you have class today with your professor, I highly recommend you guys ask him about this problem, and then make sure you guys figure out what the formula is, because there's definitely a formula going on here. And it probably was a coincidence in your homework problem that they were all the same, especially since this is not all the same, right? So it might have something to do with the fact that it's now x cubed and your homework only went up to x squared. But that's just me taking guesses. So yeah, we have about 2 minutes left. So I'm gonna just go ahead and wrap up the review session. I highly recommend you guys go ahead, ask your professor about question 19, ask your professor about question 17, make sure that if this is even on the test, and if it is, make sure you understand what is the things we covered, if that's correct. And yeah, because those questions seems to be the ones that are a little more confusing and a little more difficult. So go ahead and ask your professor about that today. Clarify what's actually going to be on the exam. Yeah, other than that, since we're closing now with the review session, any last minute questions that we wanted to quickly run by, like really short last minute questions?
I'm good, thank you.
All good.
I'm
All right.
good too.
Awesome. Yeah. All right then. So just some general test taking tips. Again, in class today before your exam tomorrow, make sure you guys clarify what's going on with these kind of problems, if they are on the exam or not, and if they are, how to solve them. If you're going to be studying these problems, don't stay up too late studying. Make sure you guys get a good night's rest beforehand, and make sure you eat a proper meal before your exam. Don't do an exam on an empty stomach. But yeah, that's all I have for today for you guys. So thank you guys for coming.
Thank you.
Bye.
No problem. No problem. You guys have a good rest of your day.
You too.